All right, let's begin. This is AI Talks, your regular monthly jab of highly concentrated machine learning news, 100% informative and exciting stories on the bleeding edge of ML tools and know-hows from SoftServe. My name is Daniel. Everyone knows me as Daniel. I'm happy to be back as your regular host. And congratulations to us as we kick off our second season of the AI Talks of 2022. Yay. I hope that everyone will agree that machine learning solutions are being created to make all our lives better and make us happier. Not all the use cases, though, for machine learning / AI are supposed to be for profit. There is a whole uncharted territory of use cases for the ML AI that can improve the living of the people who need it the most. And today we will dive into a world of public good AI. For that, I would like to invite to the stage our prominent expert, Olesya Statsiuk. Olesya, welcome. Tell us what you prepared and how machine learning can be used to make our society better. Welcome, Olesya. You can go ahead and share your screen.
Thanks a lot. Yeah, thanks a lot for such a warm introduction. And just a sec, I'll do the necessary stuff. Welcome, everyone. And I'm happy to share my experience. I'm happy to kind of spend the next hour together. And what I'm hoping that it will be, while we will be discussing quite a serious issue like poverty prediction and all the kind of technical and practical implication of that, I'm happy we're gonna have some fun along the way, and it's going to be interesting. And you'll get some useful information, how to basically what's the limitation, what's applications, all that stuff. So what's our agenda today? We'll start at least from the understanding what's this AI for social good, basically what does it mean? Then we'll dive a bit into comparison. We all are, each of you involved into commercial projects. And is it AI or any kind of project in social direction, social domain different? What's its complexity? And basically why we are here, we understand what's the place for ML there, how ML could help. Then we touch a bit on data-centric approach, why it's a bit more beneficial for AI for social good. And also then we dive directly towards our use case regarding poverty prediction. I will be talking mostly about the project I've done, like it's been almost 2 years ago. It was done for South Africa. I tried to replicate some stuff for Ukraine, but it will require much more work than it was. It needed to be done for South Africa. In order to understand a bit more what's under the hood, for all this stuff, I'll walk you through this data processing. So we'll talk about data sources, tools, all the stuff. I do think it might be a bit more interesting for the data scientists, but I tried to make it visually pleasable also for everyone to feel that basically with quite a simple tool and with a bunch of already open information, you could achieve good results. So it's there. I'll talk briefly about all the models I've done with the data. We'll discuss the results and to kind of sum up in a positive note, I'll present a few less or more successful cases. I'm a bit stressed, but not too much. So I think I'm really hoping it will stop like in a few minutes. A few words about myself. Basically, I'm a former physicist, so I too like all the math, coding, all this complex stuff, modeling. That's kind of my jam totally. That's for sure. And for the last 7 years or so, I've been working in data analysis, machine learning, deep learning, in computer vision mostly. But also it was NLP, it was analytics, all the stuff. That's a few words about myself. So let's understand a bit more what's this what this acronym is basically. In order to understand it, we have to kind of step a bit far away and look and understand what social good means basically. And there is quite a common definition of that. We have defined 17 goals by United Nations, and they kind of aimed to be achieved in 2030. I think it's kind of envisioned, pretty challenging, I'd say, and like COVID was not planned when they basically started all this planning stuff. In any case, there are 17 goals. They are quite diverse in the domains. They are different. And the first goal was about eliminating poverty, basically. That's kind of an overview. And also, you could imagine that all this social good here, all this like eliminating inequality, poverty, like environmental issues, all this stuff are highly debatable and could have a quite high impact. So in order to support this kind of research, this kind of development, were developed the whole range of ethical principles, guidelines, policies, all that stuff. We won't be digging into that like almost at all. We'll dive mostly into practical implications. And we'll try to understand why ML could help, why it's not, where it's limitation. But just to give you an idea about like some ethical backgrounds, so we have at least 4 of them. So solution has to be genuinely not bad. So in order to see, while you are developing in your host, you have to understand that it's for social good. So there should be safeguards, there should be consent, all that stuff. All the requirements should be tested. So it's additional layer of protection should be adopted. It should be quite autonomous. And if you have to collect active user feedback, otherwise it's just nothing, most probably. Justice of, okay, and also explainability should be a bit higher than in regular commercial projects, because usually this kind of projects are challenged, battled with a bunch of critique, bombarded with contradictory, all that stuff. So it's all these ethical principles should be included. And what next? You might. We were starting, if you remember, probably we were starting from the 17 goals. Then to understand, okay, this goals eliminating poverty, all the stuff sounds a bit more generic and potentially like to what's in them. So here, McKinsey made quite an extensive report regarding what exactly, what articles, what initiatives, what research was targeted, what issues. And there you could see kind of an overall statistics. You see that, yeah, indeed, hunger and health are the most challenged, and along with environmental issues are the most popular ones. What I was surprised to see that they only found out, along with like 160 researchers, only 4 of them were aimed for detecting false news and some polarizations. I do think it's not enough, but yeah, that's what we have at this point. And mostly if you are thinking about the social initiatives, about you thinking about all the researchers, all the NGOs, all that stuff, they usually respond to some crisis. Usually they respond to some challenges, educational, environmental, and usually they are targeted to get things better on a bit higher level. So that's basically. Also, if you want to understand like what kind of ML capabilities could be used in social good, average of them. So it's it's data. So why not? Here you could see a bunch of statistics which are less or more popular ML algorithms, techniques, and stuff used for different kind of domains. Usually it's okay. It's of course it's all the classics from computer vision, like object detection, classification, from the NLP, like definitely all the structured deep learning, working with high dimensional, diverse, tabular data. Sure, the reinforcement learning, because we do have a bunch of works devoted to like social interactions, all the Twitter, all the graphs, all that stuff is also there. So here ML could help like with all the tools developed. So not a huge surprise. I'll give you a second like to scan a bit through this slide. The idea we've started from these 17 goals. Then we saw that there is a bunch of domains covered, but what exactly are what exactly researchers like on a granular level? And here I listed a bunch of researchers for the last few years for you to understand kind of on a more granular targeted level what are these researchers are. So about penguins, about elephants, substance abuse, pandemics, social media analysis, some like a lot of stuffs could be covered and are already trying to be improved. Here, I want you also to take a few seconds and try to remember kind of the worst project you have in SoftServe or in other company. The most complex one, not in a good way, complex one, but in a way of a lot of like stuff were just going like not so good. And then on the right, you could see this circle with the whole bunch of stuff which is impacting any project, like number of methods, uncertainty of scope, politics issues, availability of resources. All this stuff could like make any good intended project like a nightmare. I do think like every each of us had such experience when you understand, okay, it could go so way better, but we had what we have. Regarding AI for social good projects, they are usually way more complex than our regular commercial projects for a bunch of reasons. They usually way more complicated on a different levels. And the next slide, I'll highlight a few more examples for that, so you'll see what's the difference. And the idea is for me to convey this feeling of that it's not kind of wrapping up a complex project within a SoftServe might be a challenge. But wrapping up a social oriented project within some organization, all this stuff might be just huge challenge, much bigger one. So here I listed like a bunch of differences. Of course, they're not all the differences, but you could imagine you have a usual chain of responsibility for the project. When we are doing regular project, we have our team, we have our client, maybe some other providers, etc. So usually it's to some extent clear. For social projects, we have NGOs, we have researchers, we have huge companies, we have governments, we have a bunch of institutions which are to some extent involved, or could be involved during the project, or will be involved after. So it's not, and it's already getting a bit more complicated. Regarding the project design, in our case, usually it's bottom up, means namely we have a data. For example, a company has collected a whole bunch of historical data, and okay, could we use some ML here to automate some processes, or could we not? It might be not the case for social-oriented projects, and each of the data scientists or ML researcher who is here, every of you knows how hard, what a pain in the ass is all this labeling stuff, all this getting clean data, all this, and for the social project, it might be worse for a variety of reasons. Also, for our projects, a lot of questions are just engineering stuff. So you have money, you have MLOps, you do the stuff. Yes, of course, it will require like meetings and meetings, but it's technical stuff. It's not so easy for social projects. And also, as I do think that one of the most important difference here between two directions of the project is that in our case, with commercial projects, we usually try to figure out who will be the user, like at the very beginning, or at least to be prepared for some changes. We understand who and how will be using, or at least we are trying to get that as fast as possible. It's not so easy, it's not so simple, might be, because for social-oriented projects, because for them, end users might be like a variety. It could be just humans who will be using the stuff. It could be researchers, it could be government, it could be NGOs to some extent. So, and imagine you have not like one type of end users, but tens, and they're not agreeing on stuff. Like it sounds like a nightmare for me. So when I saw a bunch of projects which made to the end and started bringing value, I was like, wow, guys, I'm totally with you. I feel you, understand you, July, and that's a kind of, it's a lot of work they're doing. One more thing, one is also what's like an issue, always an issue. I couldn't stress enough how data complexity scope is an issue in any kind of ML project, especially for this one I'm talking here about. You could imagine, okay, what's the data scope? You have to collect this data somehow. That's already might be a nightmare. You have to label it sometimes, but most often you have to kind of index it, make a catalog. You have to store it somewhere. You have to regularly update all this cycle. It's there, and it will be always there. So you could imagine that without good data, even the most state-of-the-art-ish, the most like prominent algorithms are nothing. So all this work is very time-consuming, super complex, could be tedious, etc. And for social-oriented project, it's even worse. And somebody has to do all this stuff in order for us, humble machine learning researchers, to do their POC and to test their models, etc. Somebody has to do this work, and that's a lot. And also, you probably wondering, okay, or not, I don't know. Probably you're wondering, okay, where is the ML? Where is the ML there? Because I was talking about ethical principles, about these goals, about all this complexity, about why it's hard. ML is here, ML is there, yeah. But what happens more often than not, that we are expecting that we have idea, we have data, we test our ML, and we have some impact. And in reality, it's not like that at all. And more often than not, we are facing this situation when a rather very simplistic solution, but with a lot of accompanying helping infrastructure, is working much better than some super cool stuff without any support. So that's why I was talking about the complexity of the project, because in order to get to this sweet point of impact, to see that it's finally doing something, not just sitting there, you have to think. We as data science, even we have to think wider, and we have to understand that we have to understand that data is more important than all the last articles. We have to understand that how could we basically build more data-centric approaches as compared to model-centric. There are projects for which model-centric approach will work. So the main difference, like we in one iteration we fix the data, and then we start to come up with the best model possible. In other iteration, we are trying to improve iteratively, but we are mostly concentrating on the data, on the quality of data, the consistency of data, on the feedback loop, on all that stuff around the model. And from what I've read, from my experience, I understood that usually data-centric approach for social projects are much better. And when you are thinking not a model-centric but a more data-centric approach, imagine you come up to like starting to design this project. You will be thinking about like how to validate the data, how to collect feedback as soon as possible, how to ensure that the new data which is coming through is like close enough to the one model already seen, or it's not close enough. So you will be thinking differently if you are kind of in this, is this a word, paradigm? I think so. If you're in data-centric approach, and it will kind of shape the way you're approaching the project. And I do respect model-centric approach like a lot. It's super fun to see that you could gain a few % by like more under the hood tips and tricks. But real life project, especially ones which might be impacting humans, like as end users, should definitely be data centric. Okay, I hope you are still here with some of you. Finally, we are getting to poverty prediction. The question is why we need it? Yeah, why it's important? What could help us with that? Like, okay, is it usable or not? Like, or it's just some fancy stuff. What's the main kind of challenges? If you look at this world map in the slide, it's a heat map showing how many surveys were conducted for 10 years in different countries, trying to understand the level of poverty in these countries. And could see that for Africa, it's like 1-2 surveys per 10 years. So what does it mean basically for us? That we have no idea. Not only we, but some apps have no idea what's happening there really. So you may imagine and these surveys are time consuming, like hell, very costly. It's a huge methodology, etc. The survey I will be using as ground truth. I found out that in order to calculate wealth index for some household, it's like 70 pages of explanation how they basically, from a bunch of indicators they saw, they question, etc. They fill up that that wealth index. It's a crazy work, And in order like to battle the problem, we have to identify, we have to scale, we have to label it, we have to be able to compare. At this point, what I understand from what I learned during this project and during preparation to this presentation as well, it's not a simple question, and it's not still kind of done. It's just a few attempts here and there to do it, but it's an open question still. I've noted a bit regarding data sources I use. So as a ground truth, I use demographic and health survey. Usually it's conducted every 3-5 years in some countries, and it's a huge research. A group of researchers went to a whole range of households on the country, fill the huge questionnaire, etc., all the stuff, and that was my ground truth. As data on which I tried to predict this ground truth, I used three different sources. First one was nighttime luminosity. Basically, there is a huge indication that nighttime luminosity for a continent, for a country, whatever, is a huge indicator of economic activity. And it's logical. Why not? Also, I used satellite images, a lot of satellite images, and also there is a whole range of researchers using satellite images. Remember, maybe you remember the screen I showed you. There were the first was about penguins, and basically an author also used satellite images. I once spotted that satellite images economy or something of that sort. So it's a huge direction. And the last one was OpenStreetMaps. Probably all of us know what OpenStreetMaps are. They are crowdsourced maps. And at this point, I found out that it's like 80-90% they covered a lot of stuff, and for some countries it's only like 40% of the information are covered. What's especially like super cool about OpenStreetMaps, like I do think it's like quite a magic, and because it's free, it's open source, and it has a bunch of information. All the roads, all the buildings, all the points of interest, all the water, all the connections. So it's like it's quite a lot. So you could get all the information about a city, country from OpenStreet. Like that's cool. Regarding instruments, basically, I've used mostly the first one, QGIS. There is whole variety of the instruments working with GIS, it's Geographic Information Systems. The first one, QGIS, it's an application. I'll tell you a bit more how it works, etc. GeoPandas, every data scientist knows pandas, and that's GeoPandas, geo version of pandas. So it's cool because you don't have to come up of your bubble with pandas, NumPy, all this useful stuff, but you just use another library, and PostGIS, of course, why not? Regarding QGIS, that's the one I used the most. Why it's cool? When you're working with geospatial data, more often than not, you have to be able to compare different layers of information. Imagine on one layer of information you have water stuff, and another layer you have some another stuff, and you have to be able to process these different maps as a one map, to be able to calculate some distances, some fun statistics, etc., within the layers. I'll show you in a bit how it looks like. So basically, that's a screenshot from this QGIS application, and here you see a whole range of different layers, and you just merge it all together. You could visualize, you could see okay, it's that and it's that. In my research, I used mostly three algorithms. First one was buffering, second one distance to the nearest hub points, and join attributes by location. Why I need them? Just a short note. For data scientists, I'd say that if you ever are going to work with geospatial data, try this out. This application has an extensive documentation. It's not very easy to install, and because iOS is saying it's not trustful and all that stuff, but it is. Don't believe iOS, as I believed at the beginning, Microsoft. And in any case, about algorithms. About algorithms, buffering. What's the buffering? Why I need it? Remember, I told you about a lot of people coming to households, asking them stuff, etc., collecting their data. And when they did that, they basically they basically labeled each household, either it's rural area or it's somewhere in the city. And then they basically said, okay, we asked the people around this area, and it was a rural area. So let's spread, like, kind of extrapolate the data we have for 5 kilometers around the household. So in my case, I had two different kind of buffers, small ones and big ones. And in my case, for the research, I have to, all the other data I showed you, this nighttime luminosities, OpenStreetMaps, all that stuff, I had to be able to kind of merge all together with, we have our cluster from the household, and we have other information. So these households, the geographic coordinates of these households were my kind of ground truth and were my point of interest for my targets. That's why I need this buffer. Distance to the nearest hub. Imagine you want to know from this household, from this centroid, how far away is there some road, how far away is school, how far away is stuff. So these are definitely indicators which are important to predict poetry. The same you want to kind of get in general statistics or summary of the stuff around household. So here there is a screenshot with, you see here there are small circles. Small circles are households from the city mostly, and this one are like bigger ones from the more rural area. So I processed all this data, and in order to predict the poverty, I was aiming to predicting in more regression-like model, not wealth index, education completed, access to electricity, access to water. So these are 4 factors I was looking for. I think it's just beautiful, you know. And maybe no one agrees, but I think it's beautiful. And that's how in 2016 South Africa was looking through from the it's night perspective for it. So we have somebody is trying to get me in Teams. I hope there is nothing serious. Okay, so basically what had I do? I said, I think I have some. Oh no, I don't have a lot of time. Okay. I'm trying to speed up. So collecting the data, upload a huge TIFF file. It's like a few gigabytes. Have to found South Africa there, and later on I have to. This is a cute image, but cute image with these clusters for poverty survey and around Johannesburg and night luminosity data. And regarding satellite images, there's also an example of it. So like also a huge source of the information. And the last picture is from OpenStreetMap protest in QGIS. You see all the black is usually blue is roads. These are our clusters. Orange are build some buildings. Point of interest are green ones. Point of interest is churches, educational stuff, shopping malls, all the stuff like communal stuff. It's pretty understandable that it's important features. Okay, just a sec. So after I processed all this stuff with QGIS and basically what I had a name for my class, a name for my survey cluster, and then I had a bunch of information, a bunch of statistics, a bunch of stuff for that cluster. So that's basically the models I used. It was the one I tried to do separate models per each data source, and one was combined nighttime luminosity and OpenStreetMaps. A bunch of models, a bunch of experiments, XGBoost, random forest. For daytime, I used VGG. It was as authors of the article proposed. Here on the right, you could see Pearson correlation coefficient for the OpenStreetMap and nighttime lights model. How to look at it? Pearson correlation means linear correlation between a wealth index and a feature. So are they are moving together in one direction or not? Are they correlated? Doesn't mean that one goes to another, but they at least correlated, so they have impact on the final results. Roads, first were roads. But what I was surprised quite a lot, that education point of interest made it to the second. I was, wow, it was a pleasant surprise, because once I remember watching Bauhaus documentary, and architects were discussing how they impacted by building a sport complex, how they impacted the level of criminal activity in Brazilian favelas. So basically, it was a huge, significant impact. Just building a very beautiful sport center, free one, it helped them to not eliminate, but significantly kind of decrease criminal activity. And just a very cute picture. Was in Helsinki, and while wandering around, we stumbled upon this library. It appeared to be just a library, public open library. So, and at the daytime, it was full of people different ages, and it was it was a super cool place. With co-working, with workshops, with a huge library, and I would live there, to be honest. It was beautiful, and it was full of people of different ages, and it was very inspiring to see that potentially in Helsinki they already have enough shopping malls. You see, because in Kyiv we most obviously we are not having enough of them, but so that's why maybe they decided to build a library. But it was cool. Just we'll skip through the slide very fast. It's from data scientists. I've used a bunch of statistical methods in order to get those data. Findings. A few words for my findings. The main kind of metric I was looking for was R square. Basically, what does it mean, and how many, to which extent features, like all this data about roads, all this stuff, could explain the variety, the dispersion in the wealth data. Are there good explanations or not? Basically, that's it. And it appeared a quite good explanation. They could be that even 20-30% could explain a lot. This stuff is mostly for data scientists, I don't think. So what issues I had. Daniel, do you have still a few minutes, because I'm like, I'm not.
No, you have 10 minutes. Go ahead.
Oh, okay, thank you. Because okay, regarding approach limitation bias, you could. It was a lot of issues with data. Honestly, at first, at a general level, it's rather sparse. There are still some uncovered dots with satellite images. OpenStreetMaps are not full. All this stuff, and also it's updated not very frequently. So it's not like you're getting like your historical data just from the hot of the from the oven, as it's rather often happens during commercial projects. One also aimed for some more regression approach, and when we moved towards the project, the client was like, okay, it would be much nicer to have some probabilities, etc. I think, okay. It was also, so the usage was kind of also a limitation. Also, each data scientist who tried to replicate some stuff, initial article, even if this article has supporting code and it looks good, knows that it's not immediately easy. It's very often a lot of stuff is hidden, and in my case it was the same. I was like, oh, okay, I have an article and it's clear. I have the repository. It seems okay, but all the important stuff in the issues also are answered in this repository. Otherwise, I wouldn't be able to like understand, okay, how could they get from point A to point B? It wasn't. Also, you could see that with OpenStreetMap, you could generate a whole range of features. So it could be like some fun stuff, some etc., because you have a lot of data. And due to time limitation, I used like very high level. So there is definitely room for improvement. Modeling, of course, yeah. A lot of also could be done there. That's for sure. And the last, but not the least part, before we go to this, I would say that like to sum up a bit this poverty prediction project, let's say that at first I saw that all the geographical and geospatial data is a huge resource and source of information, and there are tools available. We could work with it, and there are problems, a bunch of problems, not only poverty prediction, ecological ones, etc. They could be approached from this side. So it was wow. It was very applicable. It was practical, and it's kind of a good. It's kind of a good thing. Have to have it under the hood. You understand? You could approach it. Also, I got to understand that it's not simple like to build the model, and that's it. And for poverty prediction, it does have a bunch of limitations into usage, into understanding all that stuff. So moving back to other problem, but maybe some of you are wondering, is there some successful projects? Like, you know, because I've mentioned, and I tried to kind of unload all the complexity of the social oriented project and show you a bunch of stuff, and potentially some of you started thinking if they're not, or some good ones. There's a lot of text. I know it's not a good practice, but yes, there are a bunch of cool projects done by a lot of people around the world. And I would say from what I found out for the last 2-3 years, it's starting to speed up. For example, Google reported like for 19 year in 2019, they supported like six projects or so. In the next year, it was 30 projects they were supporting. Climate change AI appeared, like a lot of initiatives appearing, and a lot of good projects are speeding up. So it seems like this direction is accelerating. So there are people willing to invest their time, their money, their organization willing to also improve on it. Of course, as I showed you, ML is not the most important part there. No, it's not. But ML definitely could be helpful to raise questions, could be helpful to make research more organized, could be helpful also in a lot of ways. For here, therefore, projects like random ones listed, they're quite different. In one it's more educational about engagement for young people for increased flood. It's like a crucial issue for a bunch of regions. Google research with a project for typical speech. Climate change, as I mentioned. So there, it is out there. It's getting more support from huge companies. It's getting more support from people, from government, etc. And I hope that also we could make, if possible, some impact as well there. That's kind of it, I think. Thank you a lot for your time.